This is a quick tutorial on factoring. Factoring is the breaking up of a number or an expression into parts that could be multiplied together to get back to that number or expression. For instance, 2 times 3 is factored form of 6. We can also break up expressions like this, like we have here number 1, into parts that could be multiplied together to get back to that. Why do we factor? We factor for all kinds of reasons, but one common one is to help us simplify. We factor all the time when we are, without thinking about it, when we're reducing fractions. Another reason we factor is if we have a quadratic or a polynomial in factored form, then that makes it easy to solve for x because we can just set each factor equal to 0 and solve that way. Okay, so how do we do it? The first thing you do every time you are trying to factor is look for any common factors in all the terms. Is there any number that goes into all 3 terms or any variable? We see an x in the first 2 terms, but not the third. We see a factor of 2 in the last 2 terms, but not the first. So here there are no common factors. Now we need to think about that this is in standard form. And remember that the standard form of a quadratic is ax squared plus bx plus c. So here you want to identify a, b, and c. A is the coefficient of x squared, so it's understood 1. B is negative 2, and c is negative 48. Okay, now I want to remind you, after we've gotten to this point of this little rhyme, that we're going to be looking for factors of AC that add up to B. After you've identified what A, B, and C are, every time you're looking for factors of AC that add up to B. So here, we can see, we multiply AC, by AC I mean A times C. So we're going to write that over here, 1 times negative 48, which of course is negative 48. We're going to write out the list of factors, 1 and 48, 2 and 24, 3 and 16. If you see as you're going, if you find a factored pair that adds up to B, you can stop there, but I'm going to keep going, 4 and 12, 6 and 8, and that's all of them. So notice that the 48 is negative. Also, the 2 is negative, which tells us we're going to have to deal with some negatives. Since the product is negative, we know that one of the 2 factors has to be negative. They both can't be, but one will have to be. And we can see that if you make the 8 negative, then when you multiply those, you get negative 48, and when you add them, you get negative 2. So in a problem where the leading coefficient, or the A value, is 1, once we have found the factored pair that adds up to B, all we have to do is write those in the parentheses. So x plus 6 times x minus 8. And that is factored form for x squared minus 2x minus 48. You're done. Here for this second example, we start the same way by looking for common factors. 6x squared, negative 17x, and 12. There are no common factors, so now we move on. I just realized I need to make a correction in the next. Okay. Okay, so now we're going to start the same way we did previously. Identify A, which is 6, B is negative 17, and C is 12. We're going to do the same thing. Factors of A times C that add up to B. This time, A is 6 and C is 12. So we multiply those and get 72. And we are going to list out factors of 72. 1 and 72, 2 and 36. But another factor that comes to mind of 72 is 8 times 9. And I'm noticing that I'm trying to look for factors of AC that add up to B, and B is negative 17. So 8 and 9 would add up to 17. If if we made them both negative, then negative 8 times negative 9 is positive 72, and negative 8 plus negative 9 is negative 17. Now, unfortunately, we can't stop here and just write those straight into the factors. We need to take it a step further. So there's other ways to do it. If you want other ways, let me know, but I'm gonna show you the box method. And the box method is just where you draw a box and divide it into 4 squares. In the top left square, you write your first term. Let me see. Which, I'll just do some highlighting. We're going to write our last term in the bottom right square, and then we're going to split up that negative 17x using the negative 8 and the negative 9 in those 2 spots. So let me talk you through this. I'll slow down here for a second. In the top left, we're going to write our first term, so 6x squared. In the bottom right, we're going to write the 12. In the other 2 leftover spots, we're going to use our factored pair, our factor pair, negative 8 and negative 9, to split up that negative 17x. So I'm going to write negative 8x and negative 9x. Notice that is, that adds up to negative 17x. So that's why that worked. Okay, and now all we do is look for common factors in each row and common factors in each column. So let's try this. In the bottom row, we can see that negative 8x and 12 have a common factor of 4. Since the leftmost term, the 8 is negative, we're just going to write negative 4. We're going to factor out a negative 4. And you just write that greatest common factor immediately to the left of the boxes. We're going to do the same thing on the top row. Look for the greatest common factor, and we can see that that's 3 and 3x. Now we're going to do the same thing for columns. The left column, we're looking for a common factor between 6x squared and negative 8x, and that is 2x. And the next column, negative 9x and 12, so 3. But again, here, since the top number is negative, we're going to make that a negative 3. And these are our factors. We're going to write them in factored form, just writing 2x minus 3 and 3x minus 4. And that is your final answer. You should always check, but I'm not going to distribute that back out just to confirm, but I don't want to spend time doing that right now. Okay, last example. Start by looking for a greatest common factor. And this time you should notice that there is a common factor. All 3 terms have an x, and all 3 terms can be divided by 2. So we divide those all by 2 and pull that 2x out, or by 2x and pull the 2x out front, writing what's left inside the parentheses. So inside the parentheses, we're left with 4x squared minus 8x minus 5. And now we continue using the same, what we had done previously. Identify A, B, and C. So A, the 2x stays up front, so it's no longer part of, we're only looking at what's inside, the quadratic inside. So A is 4, B is negative 8, C is negative 5. We want factors of AC that add up to B, so 4 times negative 5 is negative 20. I'm going to write factors of negative 20, factors of AC, 1 and 20, 2 and 10. And actually right there, maybe we see that 2 and 10. If we want them to add up to negative 8, so if we make the 10 negative, then they'll add up to negative 8, and just confirm that positive 2 times negative 10 does equal negative 20. So there is our factor pair. So we've done that. Let me just point out, we've done factors of AC that add up to B in all 3 situations. This how is like the previous one, number 2, the leading coefficient, the A value isn't 1, so we have to use it. We can't just write our answers immediately into parentheses. We need to use the box method. So here I'm drawing, going with a different color. Drawing my box. First term, which is the 4x squared, goes in the upper left. Last term, which is the -5, goes in the bottom right. And the 2 and -10 x, and make sure they both have their x's with them, go in the other two boxes. And now we're just looking for the greatest common factor in each row and in each column. In the bottom row, there is no common factor between 2x and -5, so it's just 1. In the top row, I see 4x squared and -10x, so they both have an x, and they both can be divided by 2. In the left column, the greatest common factor is 2x. And in the right column, -10x and -5, since there's a negative on top, it's going to be negative, and we can see they both have 5, so -5. And those, those are going to give us our factors. So we can just write the 2x minus 5 and the 2x plus 1, but don't forget that that was only factoring the inside, so we still have that outside factor that we have to account for, and that now we are fully factored.